Yes. So now we have streaming. Now I want to check if everything is okay. Just a second. Yes, yes. Now we have streaming. So hello everybody. Um, today. Yes. Today we finally, after long time of struggling with different technical problems, we start our streaming of our lecture from ESM studio here at Lviv Music Academy, and we are very glad that today we host fantastic composer, lecturer, and creator of modular synthesizers, Krzysztof Gawlas from Cieszyn. Krzysztof, so it for personally for me it was a surprise when I first time heard that Krzysztof started to work on modular synthesizer, because mainly I know Krzysztof as a fantastic composer of acoustic and electroacoustic pieces, and never saw him working on analog with electronics and so on. So it is really fantastic. Welcome, Krzysztof. Thank you for being here with us, and please tell us something about all these things.
Hello, Ostap. Hello, everyone. It's nice to have you in my studio. This is my home studio in Cieszyn. We decided with Ostap that I will be talking about the music that you heard last week from a video recording, which was realized with my modular synthesizer. Actually, it was not only the synthesizer, because I am using computer as a tool for specializing, mainly for specializing, also some live sampling and some effects, but this specializing is the most important thing, which I don't have on my modular synthesizer. I decided to make kind of simplified patch resembling some techniques that I used in music, in the music that you heard last week. And yeah, let's start. Forgive me, I am using my laptop camera to show you everything. So there might be some problems with that, but just tell me if you don't see anything. So let's have the camera and see what's here. Let's start with the lower part of the synthesizer, and the small green module that's here. It's mutable instruments ears. Can you see it?
Yes, yes,
Yes, you
we
can.
can see.
So it's mainly contact microphone, which is here on the panel, on the back side of the panel. but with some additional extras. You can, for example, use it as audio input to the modular system. You can connect here external audio, for example, electric guitar or anything. But I'm using the contact microphone this time. So the output, the audio output of this contact microphone is connected to another module here with the orange cable. And another, I have two additional outputs, which are envelope and gate signals. I'm using the gate signal to operate on the same module. Probably you should see the module. It's also mutable instruments, but this time clouds. And clouds is a granular processor. It takes incoming signal, audio signal, and kind of records it in a buffer and makes uses granulation techniques on the buffer. But then the signal from this cloud's granular module is coming into a resonator, which is also mutable instruments, but rings this time. You can think of rings as some kind of resonator. This time it is using it. It has several techniques of resonance built in, but this time.
Krzysztof, I have a question
Yes.
about ring. So in this case, it is some kind of ring modulator. Yes.
No, resonator. It
Okay.
block of
Thank you.
bank of resonating filters actually,
Okay. Thank you.
which makes kind of model synthesis. So you have a large bank of these filters which make kind of spectral envelope of of a signal. Well, you will hear it and know it as you hear it. So let's see how it works. So I'm opening. Ah, uh, before we hear it. Wow. Let me simplify it at first. So I'm taking this cable off. And when I tap on the you can hear kind of resonant metallic sound with a delay which depends on the position parameter of clouds module. So now it is immediate, and if this time it is delayed. Yes.
Krzysztof, you mean that now you tap on contact mic
Yes, I'm typing.
And so only this resonating
Get
can
scratch on it.
transform the sound from like tapping sound into this bell-like sound. Yes.
So this tapping is kind of a hammer that I'm using to put the resonating structure in
Aha, I
the
see.
rings module to action to resonate.
I see. And so, in fact, it is like the touch sensitive, depending on how strong you tap the contact mic.
I can tap, I can scratch.
Aha.
On the video, I was using this.
Hmm.
But this clouds module has a freeze button, and if I tap it, uh, it I have only one hand this time, so I need to use this cable that I put away. So this cable brings this gate signal inverted to the freeze input on the clouds. So if I don't play on this, it's frozen, and if I play, it momentary unfreezes. Now I'm not playing, and the sound is frozen, and I can walk along the sound forth and back and find the place which is used um, as this hammer of our resonating structure. Um, as it is a granular processor, it has a parameter density for the grains. So now density is at 12 o'clock position, and in this position it's not producing any grains. If I'm turning it clockwise, it starts to generate grains. The farther I'm turning it, the more dense the grain clouds becomes. So clockwise, it's kind of random grains, and counterclockwise, it's cyclic. You can change the envelope of the gates, of the grains. So now it's percussive envelope, and now softer. And so on. So what can we do? Can we change on the rings module? I already decided um, to use some LFOs from this module to um, change the parameters of the rings dynamically. If it's not there, the sound is more stable and dead. If I put them here, it's kind of this parameter is called position. It simulates position on the virtual resonating structure which is struck to make sound. So if it changes, you can hear that the sound differs slightly, modulates slightly. And the second parameter that I modulated is the structure. The structure sets the distance between these resonators, frequency distances. So it resonates on different frequencies, and in some positions you can catch more harmonic structure and more inharmonic on some others. Let's make them longer ringing. The fundamental frequency also changes. It's in the volt octave input of this module, I have the pink cable, which is connected with some other interesting module, which I will talk about in a minute. So I was talking quite long. Maybe something is not understood, and you need some more explanation. So please ask me.
Oh, it seems that up to this point everything is clear and fantastic.
So another module and another technique that I'm using here is, well, sounds different. It's more like real analog subtractive synthesis. This module is called Benjamin, and his author is the famous synthesizist Rob Hordijk from Netherlands. He made this module as a special circuit used by him on soldering workshops. So he is sometimes giving such workshop where he gives to the participants PCBs and electronic parts, and they solder the module together and then play on it. It's quite simple, but also quite sophisticated. It consists of two generators, very typical triangle and pulse wave generators, one filter, resonating filter, and a special special circuit called Wrangler, and Wrangler is kind of chaotic signal generator, which can be used to make some sequences or more complicated signals. I will show this. So and the thing that's interesting in it is that the signal of the audio generators controls the Wrangler circuit, and the Wrangler circuit can control back the generators and the filter. So we have kind of feedback loop, which gives very, very interesting possibilities. Let's make the first generator play a sound. Oh, we can hear anything? Something. Oh. I'm using a VCA controlled also by this model, which disturbs the sound. If I put the controlling signal off, we can just hear the sound of the first generator. The generators, both generators, operate in very wide frequency range. So at 12 o'clock, it just starts to make sound, acoustic frequencies, and on the left, it produces very low frequency. So both generators are the same. Let's make the first one produce steady sound, and the second one can be used as a clock, which controls the Wrangler. And then if I use the signal from Wrangler to modulate the frequency of the first generator, I have this effect. The filter has a nice resonance and also can be controlled with the Wrangler circuit. If I use the pulse from the clock generator as a gate for envelope generator here, and the signal from the envelope generator into the VCA, I can have this effect. These four segments the stages are used as a ADSR generator. I'm sure you know what that is. Well, and then back to the pendulum. If the clock is very fast, the module starts to behave as a noise generator. But the noise is controllable.
So it is, as I understand, this is some kind of granular synthesis in lifetime. So because you
No,
speed up
this one is
clock,
not granular.
but I mean
It's
that when you speed up the clock cut the sound into the very small particles, like less than once,
actually it
like few
seems like
millis.
that, but it's just controlled so fast that it seems like that. But you cannot, for example, overlap the grains as in a granular processor. Here, only one grain, uh, but it's
Uh-huh.
actually not really a grain, starts when the clock makes another pulse.
Hmm.
So when I'm using this envelope generator, it envelopes the signal, but if it goes so fast, it's faster that the uh, for example, decay time of the envelope generator, and the sound isn't interrupted
Hmm.
at all. It just the wrangler just changes the parameters of the filters and generators here. So this is um, the sound that comes from it. It I can show you one interesting another interesting thing in that sound, that noise sound. It's not really um, um, stochastic noise generator, but more like a chaotic generator. It has some steady states, some equilibrial states that you can make using this, and they are very interesting musically. Uh, I will show you that. For example, like this. Now, the pattern that the Wrangler makes is just a cyclic pattern of 32 steps. And if the clock generator is very fast, it works like this. But if it's lower, you just hear a cycling, repeating melody of 32 different tones. Actually, there are not 32 different tones because it's only a 3-bit um, output, so only 8 possible pitches are possible here. but the pattern, the whole pattern lasts 32 steps. But then if I put this loop offset parameter more in the center position, it starts to change, to evolve very slowly or faster. There are still the same pitches, but the pattern slowly evolves. It it works like a melody when the clock is slow, and this way if the clock is very fast. You can also control the clock by wrangler, so now the time is not steady, the rhythm is not steady, but also has some patterns.
Krzysztof, I have a question about Benjamin. You which kind of like trigger for the sound is possible to use as input for Benjamin? So is it any possibility to use like external keyboard?
Yes, also it has outputs here on the green the green part of the module. These are outputs. So these are triangle and pulse of the first generator, triangle and pulse of the second generator, a PWM signal, which is it's we have not enough time to explain this in detail, but there are some other signals that can be usable here too, which are the PWM and XOR, and the Wrangler CV signal, this control signal which is used to make the melodies. And it has 4 inputs. The CV for frequency control of the first generator and second generator, the CV of the frequency control of the filter, and you can connect an external signal to the filter to use it as a processor, sound processor. Here I have the first triangle output of the first signal as a frequency modulator of filter. If I turn it, I can make frequency modulation of the filter, which gives me that effect. The triangle signal has the nice effect. If I use the pulse for that, the effect will be more pronounced. So here, the audio signals and the control signals are equivalent. You can both use to make modulations, but of course, the effect of different frequencies will be different. Here on the patch, I'm using the Wrangler signal to control the rings volt octave input. which changes pitch, the fundamental pitch for rings. So the both instruments share the same rhythm, similar rhythm, and they can play together, making this music, this mechanical music, more interesting. And so on. You can play using these parameters, and well, improvise.
Fantastic. So, Krzysztof, I have the first question. So, so you already explained, because I was very curious about this wooden stick which you use for playing, and but um, do you use also keyboard,
Yes,
or
I have a keyboard controller, the keystep 32, which has CV and gate outputs, which is um, very convenient
Mhm.
in use together with modular system. But in this patch, I'm not using that.
I see.
But of
And
course, you can just connect the keyboard's CV output into the Benjamin CV generator CV input, and use it to change the pitch or change the rhythm or change the resonating structure of the resonator or anything. That's great thing about modular system, that you can modulate anything with anything, and everything gives interesting results.
mhm. Thank you. And also, I have a question. So, because in your piece there was some moment with many layers of sound structures, and so you use external processing of sound for
Yes, I have a program that I've written in Super Collider, which takes the input sound, records it into buffers, and then uses this
Mhm,
as a live sampling
mhm.
in live sampling procedure.
Great.
And also specialize all the samples in the virtual space. So that sounds more interesting than today's today's presentation, which is just two voices without any reverb or any effects.
Great. Okay, Krzysztof, thank you very much. At the moment now, I want to stop streaming on YouTube, uh, but